Are these a lot of them?
No.
But it's also
All right, ladies and gentlemen, we're looking back at the ambiguous case of the law of signs.
I lost my pen.
And today we're actually going to solve for all possible cases. All right? So our two case situations, let me just generalize this. Our two case situations look like this, in which the height of this triangle was shorter than the opposite side. So that ended up giving us two possible triangles, this skinny sliver of an obtuse triangle, and then this larger scalene triangle. What I want to point out, there are going to be some interesting properties, is that this right here, which is neither of the triangles we're solving for, what kind of triangle do you think that is? That's an isosceles triangle where these two angles are congruent and those two sides are congruent. Because the opposite side, right, has to be the same length, right? If this is like A and this is cap A is the same length in both of those cases in order for it to be opposite. So this is isosceles. And then base angles theorem says that in an isosceles triangle, the angles opposite of your congruent sides are also congruent. So that's why these two angles are congruent. So if, say, this was side C and this was side angle C and angle B, if I wanted to find the other version of C, say I'll call it C prime ends up being supplementary to the original angle C. All right? Because this angle right here is equivalent to angle C, and then my new angle C, C prime, will be supplementary to it. All right, so that's one of the facts that we'll have. So the two triangles that we have coming out of this will be our kind of larger one is our general case. All right, where we'll have A, B, C.
D. Yeah.
And then we'll have A, and you'll have the height like that. We'll have C prime is now a larger angle, and B prime ends up being a smaller angle. Here B is large, and here it's super tiny. All right, so both of those angles change. And then what other piece of information changed on us? Little b.
Pickles,
All right.
pickles.
Here little b is this big,
Pickles.
right?
Pickles.
And here little b is tiny.
Pickles.
So it's b prime here.
Pickles.
So for our second case, we're going to have three new facts about it. And that's what I wanted to point out is the relationship that C prime is supplementary to C. Now, it's not always going to be the letter C there, obviously, but those base angles.
Could be A.
Yep.
Could be Z.
Is this gonna be in my final?
Mm-hmm.
C. Everything from the beginning of the year
No.
to the end of the year.
No.
What do you mean no?
But anyways,
Special one.
so this is the general case. So let's actually do an example of this. Actually, let me write down. So in this case, C prime is equal to 180 minus the original angle C is kind of your additional fact there. All right, so that's true for these labels, but won't be true for all cases.
Maybe the same thing for B.
Well, B prime would end up equaling. Oh, that's an ugly B. B prime would equal 180 minus A plus C prime. All right, so you would end up having to re-find what B is depending on your new angle C. Because this is obtuse now, so this one's going to be a lot smaller. All right, so those are the two new facts that we're going to use. So we're going to solve, in this example, we're going to solve both possible cases of this triangle. Because we might as well, since we're able to now. So let's say A is 51 degrees, little a is 40, and let's say little c is 50. That's a degree there. Yeah. So let me draw actually a large version of this picture. So here's my 51 degree angle. So this sketch might not be to scale. What is my adjacent side? C is the adjacent side, and A is the opposite because little a is always opposite of big A. And notice that theoretically, if I find the height, I'll end up realizing that I have two cases here. Actually, I'm gonna exaggerate it like this. All right, but this is congruent to this, where both of those are 40. Okay, so that's the situation, and then I've got this height coming down.
But how do you know how to draw that?
Well, it's not necessarily to scale, but let's actually verify that there are two cases here. How would I know that? It's acute. I look at my chart. I have to figure out, is my opposite equal, longer, or shorter than the height? How do I find the height? You guys remember the formula to find the height? It was the adjacent multiplied by the sine of the angle. Right? So here's the height. So that would be 50 times sine of 51 degrees. And I punch in some numbers into the calculator. And I get H equals 38.8573. Which, because the opposite is larger than that, there are in fact two cases. All right? So the first one I'm going to find, actually let's label this a little bit. So here's A, here's C, here's B, and then I'll also have B prime here, and C prime here, and then little b prime right there. All right, so little b prime is this. Regular b, regular little b is the whole length across. So let's find the regular version first. So which angle can I find first? Angle B or angle C, or can I find little b, the whole length across there?
You can find big C.
I can find big C. You're always the one to spot that one. Hopefully other Los Estudiantes see how to do that. So let's see. Sine of angle C would equal, over 50 is equal to sine of 51, the angle A, over side A, which is 40. So I'm going to skip a little bit of work, and C is going to equal the sine inverse of what? I'd multiply both sides by 50, right? And then sine inverse both sides. So it's 50 over 40 times sine of 51. So let's plug that in, and we will find big C. Big C. 50 over 40 times the sine of 51 degrees. Listen to me rhyme. Here we go. 76.2718 degrees. So that is this angle right here. All right? Technically, it's also this angle right there. All right? All right, all right, all right. And then here's the other C prime. But we're working still with these angles. So for our outside triangle, what other information can I now find? I can find angle B. So 180 minus A plus Charlie. Charlie bit me. So here we go.
You watch that?
What? I don't know what you're talking about. I just made that up. I'm a comedic genius.
Charlie, let's go to County Road.
Actually, that's a different Charlie. That's an internet meme.
Yeah, no, the Charlie.
Charlie.
Want to go to Candy Mountain, Charlie?
Oh, Charlie. Charlie, that really hurts. Charlie!
So there's angle B. And then the last thing I can find for my original triangle is little b, which is sin 52.72 of 82 equals, and actually, which two pieces of information should I compare this to originally here?
40 over 70.
Right, compare the A's to it, right? Because that's the original combination that I had. 40 over sine 51. So I will get little b is equal to 40 times the sine of 52 point... that's an ugly 2. Man, a lot of ugly 2's today. 7, 2, 8, 2. But no loop-de-2's.
No bingos.
No bingo. I might be thinking about it too much.
What, bingos?
Because now I'm aware of the bingos. Maybe a bingo ate your baby.
Bingo?
That's a Seinfeld reference right there. Blam. 51.1983 degrees. Nah! Nope. It's not degrees. That's a side length. How embarrassing. So there's our original triangle. So that's like this border triangle right here. Okay? So that was our first case. But now I've got to figure out what is my mini triangle. So I'm looking for a new angle C, a new angle B, and then a new side B. And how do I find that new angle C? C prime is going to equal what? How could I find this angle C prime right here?
180 minus C.
Yeah, 180 minus C. Because of this isosceles-ness, these base angles are congruent. There's angle C, here's angle C. These two angles are a linear pair, and by the linear pair postulate, I know that they're supplementary, meaning they add up to 180 degrees. So I just do C prime is equal to 180 minus C. So 180 minus 76.2718, and I get 103.7282 degrees.
Oh, what is that?
Anyways, friends, so notice C prime, or this alternate version, will always be obtuse. Okay, so if it's not obtuse, that means you messed up. So now that I know C prime, I can find B prime. How do I find B prime? (180 minus angle A and angle C prime should give me B prime, right? So A plus C prime. So it's kind of the same work as all of this. It's just symmetric to it, or it's a different universe where the triangle happened to be obtuse. And I end up getting cap B prime is equal to 25.2718 degrees. Dungarees. And notice for B prime is supposed to be a really small angle compared to the original B. All right, so that makes sense. And then I just do this little setup again for little b prime. And then I'm able to find both possible cases. So little b prime over sine of 25.2718 should equal, and are the a's the same in this case for the little triangle? Yeah, right? So these are the same. This is still 40. This is still 51. So 40 over sine of 51, and I get b prime is equal to 40 times sine of 25.2718 over sine of 51. There it goes. So I get b prime is approximately 40 times the sine of second, and so close parentheses, sine of 51 in the denominator. and I get 21.9734. And voila, I've now found the alternate version of this triangle, right? I found the sliver, and notice that little b prime should be a lot shorter than little b, right? So notice this is shorter than that. All right, so I definitely recommend drawing a picture. I always draw them in exactly the same orientation so I don't get thrown off. I always put my angle down here, my adjacent to the above it, and then the opposite. Yep.
And there you go.
So, two triangles in paradise.
Those 2 tickets.
So that's it for today. There's special right triangles. Nope, that's not what I said. Law of signs in the ambiguous case
See what I made you
of
do?
the law of signs.
I made you say.